Welcome to our 10th lecture in Computer Programming 2. In this lecture, we're going to pick back up with where we left off on the batch processor program, but we're going to look at something that we didn't look at in great depth before, which are exceptions. When we dealt with the batch processor program, we had to do what we call catching exceptions, because there were some situations where the Java virtual machine wanted us to think about how we would handle it. And this is good. This is good. Let's remember what the batch processor program does. First of all, we go to a directory called input data, okay? And we ask input data for a list of files. So that's what we're doing on line 32 and 35. We're accessing a directory called input data, and then we're asking that to list its files. So here we go. If I click the Files tab and I go to Batch Processor, expand that, and we see input data and we see a list of files. Okay, now once we have that list of files, we iterate over the files. Okay, we grab the file name, we look for the location of an underscore, and then by using that underscore location, we're able to figure out which file type we have: annuity, employee, life insurance, or mutual fund. Okay? Then what we do is we call a factory method that takes that file type and it creates an object out of that name. For example, let's say that we have this first file, annuity. It's going to find the location of the underscore, and then it's going to take the string that precedes that underscore, and that's annuity. And it's going to pass that to our factory method, create monthly item. If we look at create monthly item, we see it's going to take the package name batch processor plus this file type annuity. And using something that we call reflection, it's going to create an object out of a class called annuity in batch processor. Now think about that. What could go wrong there? What if we didn't have a class called annuity in batch processor? What would we do? What we don't want to do is kill our program. That's the worst thing we can do. We want to think about how we would handle it. And so Java makes us think about this through something called a checked exception. For one moment, I'm going to remove this throws exception from the method signature here. Just a moment. I'm going to remove this. And this is going to show us what a checked exception is. Okay? You see I now have a red line. And the red line when I mouse over says unreported exception, Java lang class not found exception, must be caught or be declared to be thrown. Then we have another message, unreported exception, Java lang instantiation exception, must be caught or declared to be thrown. What's happening here is that the Java virtual machine realizes there is a risk. It realizes that we're passing a string asking the virtual machine to go find a class whose name and package matches that string and then create a new object out of it. Well, problem number one, what if it can't find a match? Problem number two, what if it can't create a new object out of that class? Maybe the class is an abstract class. Maybe the constructor is private status, private modifier, and cannot be called. These are things that we need to think about how to handle. Now, we have two options to handle it. One is locally we can put around a try and then a catch block. And here's where we think about what we want to do. The catch block will get invoked if the exception occurs, okay? But we have to think carefully. If we cannot instantiate the object here in this method, can we handle that locally, or do we want to just throw up our hands, go back to the method that called us, and say, there's nothing I can do about this, how would you like to handle it? If we can handle it locally in this method, we'll assign a try catch. But I decided that that's probably not the best approach. The best approach is the other option, which is to throw the exception back to the method that called us. Okay? Throw the exception back. Now, where were we called? We were called here on line 46. What's going to happen is if we pass in a class name here that does not actually exist, then an exception is going to get thrown on this method call. And what that means is it is going to skip every line that follows that until it sees a matching catch block. Okay? So that's one of the things about exceptions. When an exception is thrown, it skips every line that follows until we have a matching catch block. Okay? In that case, this is what we want to do here, because what if we get a new file, say car insurance in here? What if we get a new file called car insurance? Do we want to stop processing everything else just because we have an unidentified file? No, probably not. Probably what we want to do is we simply want to log the error, acknowledge the error, and then move on to the next file. Notice that we're not crashing our program. We're simply saying, I don't know what car insurance is. Therefore, I can't process it. I'm going to make a note that I can't process it, and I'm going to move on to the next file and continue with that. Okay? And then perhaps that error will raise a notification that says, hey, there's an unknown file type. What do you want to do? But you see that we've controlled the situation now. We've controlled the situation because we've said we're going to skip this file and move to the next and process that. So our program will continue to run. That's not going to kill the program. The program will simply pick up with the very next file. Let's say, for example, let's go ahead and test this theory. I'm going to rename this guy from annuity to car insurance. And let's watch what happens. By the way, this is what we will call a checked exception. A checked exception is a condition where Java sees us doing some kind of operation that contains a risk, and it wants us to acknowledge how we're going to handle that risk, okay? And it does that by forcing us to either rethrow the exception or catch the exception. To throw an exception from one method to another, we need the method signature, as we would normally have. Then we add this word throws, and then the word exception. Okay? That's how we indicate that a method might throw an exception back to the point where the method was called. That's called rethrowing exception. On the other hand, we can handle an exception by starting with a try and then ending with a catch. And that means if an exception happens anywhere between the try and the catch, if an exception happens anywhere between those two, and there's a matching catch block, and there can be more than one catch block, then that catch block will handle the exception. Okay, that catch block will decide what to do. So I've changed this file type to car insurance, and now I'm going to walk through in the debugger. We'll save my changes. I'm going to walk through in the debugger. Make sure that got saved. Yeah, there we go. I'll walk through in the debugger, and we'll watch what happens when this exception is thrown. Okay, just one moment as I go back. Okay, monthly runner. First of all, I'm going to set my breakpoint again. Okay, and then we'll run. Sorry, I chose run. I meant to choose debug. Let me choose debug. And remember, F8 is step over, F7 is step into. If you have not used the debugger yet, you're wasting a lot of time. And honestly, you will absolutely need to use the debugger in your programming assignment number 2. It would be very hard to do that one without using the debugger. Okay, first of all, I get a list of all the files in this given directory. And remember, I've programmed this now so that there will be an error, but we're going to see how using an exception will allow us to handle and control this error. So we see our first file is annuity. Our second file is also annuity. And then this third file is the one that I have changed. I changed the name to car insurance. And there we go. Third file is car insurance. We do not have a class called car insurance to handle this. Okay? So the first two iterations are going to go fine. What we're going to see is it's going to handle the car insurance by catching the error, and then it's just going to skip that and move on to the next file, which I believe is an employee file. Okay, so F8 to step over, get the file name for our annuity file, get the underscore location, find the file type, and if I scroll up here, perhaps we can see some of this in our variables window. Okay, I have to make the most out of our screen real estate here. So we see that the file type is annuity because that's what it has parsed out of the file name. Now I choose F7 to walk into the factory method. Okay, and we see that it's going to be looking for a class called batchProcessor.annuity. There's our batch processor, there's our annuity. So in this case, everything's going to work as expected. It's going to create a new instance, and there we go, store it in the variable named MI, return that variable named MI, okay, read in data from the file, which does exist, pass this to the process method of annuity. And when I F7 into this, you're going to see it's going to go to the process method in annuity. And why is that? Because we determined this is an annuity file, should be processed by the annuity class, and we do have a class called annuity, which we can create an object out of, and then we can invoke this process method. All works well. So we need to think about what's going to happen when all doesn't work well, when something goes wrong there, when we don't have a class to process. So I choose F7, and we see once again the annuity tab has lit up, and now we see it's going to iterate over the data in this file, print it out, and finally return back to our monthly runner. Okay, we get the next file. It's also an annuity. Same thing's going to happen. Now the next file is the one we want to watch closely. Take a look at this. File name is car insurance. File type, car insurance. Okay, there we go, car insurance. Okay, now it's going to try to create an object out of batchProcessor.carInsurance, but we see there is no class there. And remember, if left unhandled, that would crash the program. But by properly using exceptions, we can localize this error and then simply move on to the next. File. So I'm going to choose F7. And what we're going to see is it tries to create batch processor car insurance. But notice what's going to happen. It's not going to hit the return statement. Even more curious, remember, look at the gray line. Remember, we last saw control on line 46. Because an exception is going to be thrown, it's going to skip all of these lines and come down to a catch block. So let's watch that very carefully. I'm going to choose F8. We're going to see an exception is going to be thrown. It's going to skip everything from the point at which the factory method was called all the way down to the catch block that matches the exception. So I choose F8, and there we go. Notice it skipped all the way down to catch exception E. Okay, that's great. That's great, because if it didn't skip these lines in between, it would try to call the method called process on a variable that doesn't have an object inside of it. So we have to be very careful when setting up these try-catch blocks. We have to make sure that we put the catch block low enough so that it skips any lines of logic that cannot possibly operate properly if an exception was thrown. We have to be very methodical about this. But also notice that we put the catch block within the for loop. And why is that? Why did I put the catch block within the for loop? Because if an exception is thrown, I simply want to log that and then move on to the next file. And the next file is going to be the next iteration of the for loop. So do we always put try catches within for loops? Not necessarily. Knowing how to set up a try-catch block simply takes practice. Okay. Also, notice that it skipped the file not found catch block and it went straight to this exception E catch block. Okay. A try-catch block can have multiple catches. And this parameter in the parentheses is just like a parameter in a method call. It's a parameter variable. okay? And this object, EX in this case, or E in this case, is an exception object that is created by the Java virtual machine when an exception occurs. Exceptions have a class hierarchy just like anything else. In just one moment, I'll pull up that class hierarchy. Okay, so here we go. We see class exception, class runtime exception. Okay, now we see file not found exception extends IO exception, extends exception. So we see there's a hierarchy here, just like any other class that we have. We are allowed to have multiple catch blocks for one try. And typically they will go from the most specific exception type to the most general. Reason being, if an exception is thrown, it will be caught by the first catch block that matches the parameter type. Okay, so from this method create monthly item, I just threw a generic exception. That's more general than file not found, so it skipped that, went straight to here. Okay, so we can have multiple catches in a try-catch block as long as the parameter types are different. And typically, the most specific will be on top, the deepest subclass, and the most general superclass will be towards the bottom. Because when an exception is thrown, it's going to get caught by the catch block, the first one it sees, that matches the exception type. Okay, so here we have it. We've caught this exception because we have this unrecognized file called car insurance. And when I choose F8, we're going to see that we're going to start with the very next iteration of the loop and the very next file, which is employee. Okay, again, if I go to files, we'll see annuity had an exception on car insurance, but we can continue to process employee life insurance and mutual fund. Whoops, sorry. So at this point, it's just going to continue with the next loop iteration, okay? F8, 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 and we'll go ahead and walk this one through. Go through the next file. Now, let's say something. Let's say for some reason, okay, notice that it's looking for file employees underscore 01239.txt, okay? And we go ahead, F8. Now, just for argument's sake, I'm going to go in memory here. I'm going to go in the debugger, and this is one of the nice things we can do with the debugger. I'm going to change something in this file name. I'm going to make it an invalid file name. Okay, there we go. And we can change that on the fly in the debugger. That's perfectly fine. Now, what I'm going to do is F8. I'm going to try to pass this invalid file to class scanner. Scanner's not going to be able to find a file with this name 1240 because I just changed it. The actual file name is 1239. Okay, so watch what happens now. F8. It skips all the way down to file not found exception. That's another checked exception. Remember, a checked exception is a time when we're doing something like accessing a file store or creating an object dynamically where the Java programming language says, I want you, the programmer, to think about how to deal with this case. So once again, we simply log it, and since we're within the loop, we move on to the next file and process that. So we see that one file having an error won't crash the entire program, and that's the whole idea, okay? And then F8, and there we go. So exceptions seem annoying, but exceptions are really our friend. Exceptions are really one of the better things that we have. I'm going to go ahead and terminate the debugger session now. Exceptions are our friend because they help us to recover from situations like this, which we can control and move on. You might still be thinking, all right, I don't understand this, how to create an object exception. I don't understand this file not found exception. Let me show you some real source code from real life that might help to think about when exceptions would be nice. Imagine your mobile phone, and I have an application that I wrote for plant places where I can go around and I can capture GPS locations of plants. Seems easy enough, right? But one trick is that we try to minimize data entry because, to be honest, Plant Places is really two people. It's actually more like five, but two of us who are working on it many hours per week, and that is me and Steve Foltz, who runs the horticulture department at the Cincinnati Zoo and Botanical Garden. Neither of us have a lot of time, and we are just have backlogs of information that we've never uploaded to Plant Places, but one day would like to. So, one of the features that Plant Places has is the ability to search for a plant on Plant Places website and then associate GPS latitude and longitude with it. Okay, what does that require? That requires access to a GPS signal, and that also requires access to a cellular network. Now think about using your phone. Do you ever lose your signal? Say if you walk through the basement of Revachol or Crosley Hall, which is basically a big concrete bunker, odds are you're periodically going to lose your signal. Or you might even lose your signal for an extended period if you're out of the country and you don't have cell phone coverage. Well, as my job and my vacations tend to take me around the world, a lot of times I like to go and get GPS locations of plants. And I need to be able to handle this offline online toggle seamlessly. Okay, so that if I lose network connection because I just happen to be without a network for a moment, or I lose it because I'm out of the country or in a remote location, I can still continue to work. And here's how that works. What happens in the Plant Places application is first, it's going to try to go online to search for a plant. But a checked exception that this can throw back is a network exception or an I/O exception where it's unable to reach the network to go online to plantplaces.com and find plant search results. So if that happens, the catch is quite simple. The catch, the catch is it simply goes offline. And what that means is instead of searching on the liveplantplaces.com, it will search on a local database on my phone that has plant records. So it simply swaps from online to offline. And it says, okay, well, I can't use the cellular network, so I'm going to store all the data on the phone. Then when a network is available, I'm going to synchronize back up with the online data source. So this is a very logical case where a user can be using something like a mobile device and it can toggle between an online and offline mode purely when it receives an exception that the network's not available. Do we want it to crash the program when it loses a network connection? Absolutely not. We simply want to convert to using a local copy of data until we get a network back again. And the same thing happens in industrial strength applications. I can tell you in my day job working in point of sale that it's very common to have an online data source, which would be a central server, and then an offline data source, which would be a database local to a cash register. So it can smartly toggle between the two. If the local database is available, maybe it uses that. If that becomes unavailable, it goes to the server backwards and forwards as needed. So exceptions seem kind of annoying because a lot of times for checked exceptions, we have to think about how to handle them. But exceptions are actually our friend because they help us to write bulletproof programs. The customer I'm working with in Mexico this summer has 10,000 locations. It's a convenience store in Mexico with 10,000 locations, 2 cash registers per store. You have to think if you write a program and it's used that frequently, you're really going to have to think about bulletproofing. Because what's frustrating? What's frustrating about going to a retail store? The last thing you want is to be in the middle of a big transaction and everything dies. So these exceptions can be a way for us to think about how to bulletproof our application. Okay, so far I've taken you through checked exceptions, which are exceptions where the Java programming language forces us to think how to handle that. Let me take you through some unchecked exceptions. An unchecked exception is an exception that we need to prevent from happening. I have a tremendous risk in some of my classes here. Let me take a look, for example, at the class called annuity. Okay, notice in this class called annuity, I am splitting out the data based on the space into a string array, and then I try to access the 0 element and the 1 element. How do I even know I have 2 elements? I should have wrapped an if test around there that says make sure that we have at least 2 elements before proceeding. Because if I try to access element number 4, which is actually the 5th element, and there is no such element, it's going to throw an unchecked exception, which is an array index out of bounds exception. And that's one that we need to try to avoid, an array index out of bounds exception. Okay, we should be more proactive. We should check the length of the array before we try to access specific array elements. So let me save this, and now let me go back and run this program again. Okay, I'm going to go back and in Monthly Runner, I'll right click and choose debug. Okay, let's watch what happens. Okay, I choose F8, F8. The first file we're going to get is that annuity, F8, F8. It creates the annuity no problem, reads the data, reads in the first line of data, and then invokes process. I choose F7 to step into this, F8. Now take a look, I've split up the data and put it in a string array called all data. Let's see how big that is. Okay, I come to variables, which is a bit off screen. You see here, all data has a 0, 1, and 2 element, but here I'm trying to access element number 4. Okay, I shouldn't be doing that because I haven't verified that I even have that many elements. This is how viruses are sometimes written, is that people try to go beyond memory allocation and keep reading. Java won't allow that to happen. What Java is going to do is it's going to throw an unchecked exception called an array index out of bounds exception. And what you'll see is that we're never going to reach line 22 or 23 because this is going to throw an exception and it's going to go back to the method that called this method process. So we choose F8. Remember, it's not going to go to line 20, 21 or 23. It's going to go back to the calling method. F8, boom. And there's our caught exception. And here we see it's an array index out of bounds exception. So an unchecked exception is one that we should avoid by good programming. We don't have to catch these, but we should avoid these by being better programmers. Okay, let me go back to annuity again. And now I'm going to change this back to where it was. We'll make it access all data 1. And first what I'm going to do is I'm going to say if all data, let's do length. Okay, so we can, oh come on, that's not what I wanted. Length will tell us how big it is. All data, that length, is greater than 2, which means we have at least 2 elements or more. Then we can do this. Otherwise, we might want to put in a log statement or something like that. Yeah, we can system out print line, unable to process, not enough information in file. And I realize that fell off a little bit. Alt-Shift-F to reformat. There we go. Let's look at one other unchecked exception that you might have seen before. Notice that we're trying to parse this third argument to a double. Well, what if in the file, let's take that very first file, what if instead of the straight number 1200, what if we have invalid data like foo? Let's watch what's going to happen in this case. Okay, I go back and source, I'm going to go to monthly runner. Let me debug this again. I right click and I choose debug. Okay, so F8, get my list of files, F8, get the first file, find the underscore, get the file type, create an object, read in the data from the file, read the first line, pass that to the process method. F7 steps me into the process method. Split our data, and let's take a look at what the data is, or what the data are, said properly. And we see that we have Element 0 is Phil, element 1 is Smith, element 2 is foo. We can't possibly turn foo into a number. So, do we have at least 2 elements? Yes. So we can process. Get the first data element, get the second data element. Now take the word foo and try to make a number out of it. That's impossible. That's impossible. So what it's going to do is it's going to throw back an unchecked exception. This time, it's going to be a number format exception. So I choose F8, and sure enough, number format exception, and notice it comes to the exception block here. Now, because I have this catch block within the loop, it's simply going to move on to the next file, and it will process that properly, and then the next file, which was our car insurance, and then which it threw an exception on that. But then we go to the next file and the next file, and we see I'm going through this quickly, but we see even after it has a problem with one file, it can continue to process the others. So, checked and unchecked exceptions. Let's take a look at the slides for this class and learn a little bit more. Okay. First of all, I'm under our computer programming 2. I'm going to click on exceptions. We'll come back and see errors in just a minute. This is what we were just talking about. Java's error trapping system is called exception handling. And we know that there are checked and unchecked exceptions. Checked exceptions means we're relying on something external, say a file system, a network, a database, and we need to decide what to do in case that resource is unavailable. We need to smartly decide how we're going to handle that situation. An unchecked exception is something that we should know how to prevent, or we should prevent. And I'll show an example of how we can do that in our driver, in our vehicles program in just a minute. So that is a checked and an unchecked exception. Okay? Throwing an exception. Oh, here we go. Sorry. We talked about how we can throw an exception. And this talks a little bit more about checked and unchecked exceptions. Unchecked exceptions typically extend from a class called runtime exception. Anything that is not a runtime exception is a checked exception. Okay, that's one way we can tell the two apart. Okay, we'll look at more example of throwing an exception when we jump back to our driver program. Okay, yeah, we'll look at this as we go through. We'll look at throwing a new exception. Take a deep breath first, though, and let's go back. Okay, we've talked about exceptions. Let's now talk about errors in programming. The very first slide I'm going to go to, and again, don't think of exceptions right now. We need to think of errors. There are three major categories of errors when we're programming. First is a syntax error, and that is when we make a mistake just in how we're typing out our Java program. It's called a syntax error. The nice thing is that those are right now easy to catch. They didn't used to be, but now they are. That's what we'll call a red line. Okay, so a syntax error, very easy to catch. If I go back to, say, monthly runner, a syntax error would be forgetting a semicolon. But as soon as I do that, we're going to see a red line. A red line says, hey, you have an error in syntax here. You have to fix it before I compile. Or if I misspell scanner, there we go. Again, a syntax error. Very easy to catch because those are what red lines come from. Runtime error, this is where our exceptions will fall. So the checked and the unchecked exceptions, those would be under runtime errors. Okay? Runtime error means you're running the program and something goes wrong. You have bad data, you get a number format exception. If you have, say, you're trying to access an array index number 20, but there are only 15 elements in the array, you get an array index out of bounds exceptions. These would fall under runtime errors. Okay, logic error is the third category of errors. And a logic error is when the program works, but it doesn't do exactly what we want. Okay, But we don't know that. Sometimes we don't know that. So be careful with this because these are hard to find. These are what we'll call bugs, and this happens a lot when we release a program, and then we realize, hey, I'm not getting exactly the data that I want. Um, I had an example of this in that Plant Places application, in the Android application, where I was not linking up. Uh, I would get GPS locations, but by mistake, I was not associating them with a plant. So I thought I was, but I went to upload them and then figured out that they weren't actually linked with a plant. Unfortunately, I didn't find this error until later. There was no red line, there was no exception, because the program compiled properly and it worked without throwing an exception. It's just that I had not properly linked up these GPS locations to the right plants. So that's a logic error. So syntax error, easy to find, it'll give us a red line. Runtime errors we try to avoid or try to handle because these are exceptions. If handled properly, we can move on with our program and do other things. Logic error. A logic error is when our program works, it executes. We don't get any exceptions, but it doesn't do what we want. And many times we don't find this until after our program is live. On plantplaces.com, I have no problem going out there and maybe making a quick change, maybe even if I'm not completely certain what I'm doing. That's because if I make a mistake, I can go to plantplaces.com and fix it. The Android application, I'm scared to death of. Because as people download and install this on their phones, I lose control. I no longer can control what's on their phone. And so if I find a logic error later, I can't go back and force people to take an upgrade. Okay? So it's very important to test thoroughly logic errors. And honestly, the Plant Places Android application I've had around for more than a year, and I still have not released it to anyone but me, just because I want to keep testing it, make sure that all the logic errors are ironed out of it before I let somebody else use it. Okay, so let's go back now. Let's go back to our driver. We're going to close off batch processor, and that's the last we're going to see of it. Let's go back to our driver program, and let's think about how we can smartly handle some things. Okay, first of all, let's remember what driver does. If I right-click and choose Run, okay, here's one very smart way to avoid exceptions in the first place. Give the user a limited set of data to choose from where all of the options are valid. Okay, this is a much more controlled environment than if I were to just let the user type in data. Giving the user a drop-down list of items, very controlled, because I know the user can only pick one of these. If, on the other hand, I told the user to type in a car they wanted, they could type in anything and I would lose control of it then. So we'll go ahead and say neon. What's the odometer reading? Okay, watch this. 40,000. Okay, is that a number? Well, to you and me it is, but it's not something that can be parsed. So as soon as we run through this, it's going to crash the program. And we need to think, how can we use exceptions to more smartly handle this situation? So I do 40,000 and we're going to see a bunch of red come up here and the program's going to die. And there we go. Notice number format exception. That's one of those unchecked exceptions. So what do we do to handle this? Well, let's take a look. You may remember last quarter I made a little range validator method. Well, last class actually from Computer Programming 1. That's something that we can do here. So instead of this big chunk where we say string odometer, what's the odometer reading? Let's rearrange this a little bit. It's going to be a little tricky with our limited screen here, but what I'm going to do is say int odometer equals validate range 0, and we'll say 1 million. Okay, and what is the odometer reading? Okay. And with that, I'm going to remove the two lines that follow. So we're going to make a method called validate range. It's going to prompt the user with this prompt. It's going to make sure that the user enters a number between 0 and 1 million. And that's what we already did last quarter. What we're going to add to this is we're also going to make sure that the user enters a valid number, not just a number between 0 and 1 million, but the user doesn't enter any text. So I click the light bulb, create validate range. There we go. Okay. And what we're going to say here is string data equals JOption pane, show input dialog. Okay. And then we'll say, let me rename these. Int low, I'll just call it low. Int high, string message. Okay. JOption pane, show input dialog message. Okay. Now I'm going to say, well, first of all, I need to take care of redline, so I will declare a return variable. Okay. And we'll say int return value equals 0. Okay. And then return the return value. Return value. There we go. Okay, now we'll say prompt the user for the given data. Okay, and then we'll say integer.parseInt. Okay, data. Okay, return value equals integer.parseInt data. Okay, convert to int. If the user entered completely valid data, we're in good shape at this point. We start with 0. We have the user enter a number, say the user enters 40. We parse that to 40 and we return. But now, let's think, what do we want to do if the user enters invalid data? First of all, what if the user doesn't even enter a number? What we can do is we can catch that here. Try catch number format exception E. Okay. And I will Alt-Shift F to auto format. There we go. What I'm going to do now is I'm going to say JOption pane, show message dialog, and we'll say the value that you entered plus data plus is not a valid number. Please re-enter. Okay, terminate with a semicolon. So if we get this, oh, sorry, I need one more thing, null, comma. If the user enters characters that aren't valid numbers, we're going to say the value you entered is not valid. Please re-enter. And then what we'll do is we'll simply call this method again. Well, there are a couple ways we can do that. Let's see. I'll tell you what we'll do. Let's set this return value to -1. Let's assume that we can't have negative numbers. Okay. That's good. Now, also what I'm going to do is I'm going to say if return value less than low or return value greater than high, we'll say here JOption pane, show message dialog, null, comma, the number you entered, return value is out of range. Please enter a number between low and high. Okay, and there we go, and terminate with the semicolon. So we're doing two different checks here. Dialog. We're doing two different checks. First of all, did the user actually enter numerals, which will be got here? Number two, if the user did enter numerals, is it between the low and the high, or is it, if it's less than low or greater than high, then it's out of range and we want to loop again. Okay? So I'm going to make a loop around this. We'll say Boolean valid data equals false. Okay. While not valid data. It's kind of confusing, but we're saying why we don't have valid data, we want to keep prompting. Okay, there we go. Okay, Alt-Shift-F to reformat of our try-catch and our if. Okay. Else valid data equals true. Do a little cleanup here. Okay. Okay. Now, I need to reorganize things a bit, though. I need to reorganize things. The problem is, as I have it now, it's possible we could catch this exception, and then we'll start, when an exception is caught, the program continues to run right after the close curly for that exception. So it's possible I could catch this exception and then reach this line, which is a lie, which just says valid data is true. I need to rearrange things. I'm going to take this if test, and I'm going to move it between the line that could throw a number format exception and the line that catches the number format exception. And remember why I do that. Okay, Alt-Shift-F is desperately needed here. Remember why I do that. I do that because if an exception is thrown from here, it will be caught here, but all of the intermediate lines will be skipped. So if I don't even have a valid number that comes out of this, I'm not even going to try this if-else block, okay? And valid data will remain false until we have good data. Okay, let's watch this work. Let's watch this work. Let's see, do we have a breakpoint up here? Yes, we do, and we have validate range. Okay, I'm going to save, right-click, and debug. F7, step into prompt user. F8. Okay. What kind of car? Neon's fine. Okay. Create the car. Now let's jump into the valid range. This is the method we just created. What's the odometer reading? Let me start with the number that's invalid simply because it's too low. Let's say minus 100. Okay. Assume the data is not valid. Okay. Oh, you know what? I just saw a mistake. Okay. Okay, hang on. Let me stop this. I need to move this prompt within the loop as well. Okay. There we go. Alt-Shift-F. You see here when we have lots of indentations, Alt-Shift-F can be very good. Okay, let me do a little bit of rearranging here again so that I can make sure everything is in scope. Of course, our friend Alt-Shift-F. Okay. Now, come on. Now, you should be in scope. Okay, string data equals null. Okay, there we go. Save. Okay, let me try this again. Right-click and debug. Okay, F7 to step into. F8, F8, F8. Okay. What type of car? Neon's fine. Okay, create the car. I'll hit my F7. Okay, assume we don't have valid data. Now, what's the odometer reading? Let's say minus 100. So we put in a valid number, but the number is low. It's too low for our range. Okay? F8. Is minus 100 less than 0? It is. So now we're going to prompt and say the number you've entered, minus 100, is out of range. Please enter a number between 0 and 1 million. Okay, so we didn't hit the catch block because that was just a logic problem. Our data was out of range. This time, I'm going to enter complete garbage data that could not be parsed to a number. What we're going to get from this is a number format exception. It cannot possibly turn all of that garbage into a valid integer. So what it's going to do is it's going to get a number format exception, and we'll get this message. But note very carefully, it's going to skip everything in between. Note very carefully, it's going to skip everything in between. Okay, so we're going to get a number format. It's going to jump directly from 149 to line 158 because when an exception occurs, it skips everything from the point in which the exception occurs until the catch block which handles that exception. So I choose F8 and watch the green line jump down to 158. And there we go. Because why even bother testing if the value's within range if it's not even a valid number? It's no use even testing that. So here we get the value that you entered is not a valid number. Please re-enter. Okay, now let's play nice. Odometer reading, let's go ahead and say 10,000. And we'll see at this point, we have valid data. It's going to skip the catch block, and it's going to return our valid value. And we can continue from here. How many gallons of gas? Let's say 10. How many miles per gallon? 20. We can let it continue from here. Do you wish to enter more cars? No. Okay. And then what it's going to do, it looks like I just skipped over that part. But then what it's going to do is it's going to go ahead and run our vehicle. So we see that we started with 10,000 and 10 gallons of gas. Then we ran 100 miles, got 5 gallons of gas. 100 miles again, down to 0 gallons of gas. So we see to make a program reliable, there are a couple things we're going to do. We're going to try to give the user, we're going to try to make prompts to the user be very obvious. A drop-down box with valid cars. A J-option pane with yes or no buttons instead of telling the user to enter yes or no. Validation of the range of data, which is kind of like a business logic decision. What is the valid range of data we could have? Also validation that the user entered a number, okay, not just a set of characters. Remember, we have to be cautious about two different kinds of users. Users who don't know anything and users who know too much. And I can tell you from reading comments that come in on the plantplaces.com forum, I see people always try to enter special characters and mess with the Plant Places forums. So there's some people who are intelligent who are trying to break your program. And then there's some people who just don't know what they're doing and don't understand computers well. So we have to be cautious about both of these types of users, and that's why we have to think about exception handling. Now, let me tell you a few things that you should never do in exception handling. Okay, first of all, I'm going to take out in our factory method, I'm going to take out the initialization of return card and null. Okay, and let's see, I'll save, and I get a red line, and I get a light bulb. Initialize, well shoot, that's not going to be a very good example. Okay, sorry, let me put that back. Okay. Okay, so two things you should never do in a catch block. Number one, if you have a checked exception, oh shoot, why won't the darn thing compile now? Actually, I'll tell you, for this I'm going to go back to batch processor. Number one, if you have a checked exception, an exception that you must handle, you should never do either of these things. I'm going to go back and force this factory to be a checked exception. Okay. I'm going to say here, I'm going to say surround with try catch. Number one, never have an empty catch block. Exceptions are very informative. They're telling us something went wrong. At the very least, you should always at least log exceptions. Once again, I'll point to my daily job. Let's say I'm working with a customer who's already rolled out our point of sale. Again, you have 10,000 stores. Odds are you're going to come across some very strange problems now and again. One of the best things that you have to detect this is the error logs. And one of the ways you populate the error logs is by catching exceptions. You should always log exceptions. If you don't, a program can die, and there's no way to tell post-mortem why it died. Many times as programmers, our job isn't programming as much as it is doing cold case files, and trying to reenact something that happened in the past. We should always log exceptions so that you know why it was thrown. Number 2, never do this. Return null. Never catch an exception and then return null. And why is that still mad at me? Okay, it needs me to catch another exception. Add surround statement with try catch. There we go. Okay. And this will keep going, but I think we get the idea. Never return null from an exception, because then what's going to happen? If you return null here, this MI is going to be set to null. And if you try to invoke a method on a variable that is not set to an object, is not holding an object, but instead is holding what we call null, you'll get a null pointer exception. That is an unchecked exception, and it is very hard to trace down. So 2 things you should never do in a catch block, and I'm going to revert this to how it used to be. You should never return null, and you should never have an empty catch block. Exceptions are your friend. Exceptions are your friend. They want you to help think about how to handle things that can go wrong in a program. If you have an empty catch block or you return null, you're taking a lot of extremely valuable information and throwing it away. So these are things that I look for very frequently when I do a code review. Okay? One other thing is there is an optional part. Let me go back to my driver. There's an optional thing on an exception called a finally block. Okay? You don't have to have this, but you can. Okay? This will be invoked whether or not an exception happened. A finally block will be invoked whether or not an exception occurred. Okay? Okay. That will occur whether or not an exception occurred. Now, one other thing while I'm in here, and I realize that this lecture is getting rather long. We probably want to give up at some point. If we keep prompting the user and the user never enters valid data, we probably just want to say, I can't help you. Okay? So what I'm going to do is I'm going to, remember, I'm back in driver now. I'm going to make an attribute, private static int attempts equals 0. Each time the user attempts to enter some data, okay, I'm gonna increment attempts by 1. Okay, attempts plus plus. Okay, did the user, or let's say, add 1 to the number of attempts. Now, if the user enters good data, okay, if the user enters good data, I will reset the attempts counter. Okay, attempts equals 0. Okay, so for one time, I'm going to count the number of bad attempts the user has. If the user goes excessively over a logical number of attempts, the user's either trying to break our system, or the user just doesn't know how to use it, and we need to take the user out of his or her pain and say we're going to kill the program. So in the finally block, I'm going to say if attempts are greater than 3, we'll say throw an exception to stop the program. So what I'm going to do here now is say throw new exception. The user has exceeded the maximum number of attempts. So if the user has more than 3 invalid pieces of data, we're going to halt this method, turn control back to the method that called us and say, I can't help the user has exceeded the maximum number of attempts. The problem is, if I'm throwing an exception here, okay, I have to inform the method that's calling me that I might throw an exception. To do that, on line 135, I add throws exception to the method signature. And now you see this line compiles. What that says is, if you call this method, it might throw a checked exception. If you call this method, you need to think about how you would handle that exception. So I scroll to the top, and notice if I mouse over, okay, well, it's not telling me the error message that I wanted. There we go. Unreported exception, Java lying exception, must be caught or declared to be thrown. In this case, I can just rethrow it back. Add throws clause, that's going to rethrow it back to the main method. And here in the main method, I can click here. Surround block with try catch. And what I can say here is jobtion pane, show message dialog, program terminated because exception thrown. Message. Okay, plus e.get message. So what we're going to do if the user exceeds 3 attempts of bad data is we're simply going to terminate the program by bubbling up the exception. Okay? Now why is that still mad at me? One moment. Oh shoot, sorry. Oh, okay, EX. I see. I should be calling it EX. Okay, now let's try it with 3 attempts at invalid data. So I right click. Let me make sure I have this guy. Okay, let's see. I will go down. I'll set a breakpoint right here. Right click and choose debug. Okay, neon's fine. Okay, now I choose F7, F8, F8. We start with attempts at 0. We add 1 attempt. What's the odometer reading? Let's put in some invalid data. F8, F8. Okay, the number you entered is out of range. F8. Is attempts greater than 3? No, attempts right now is 1. So we're not going to rethrow the exception. We'll give the user another try. Now, attempts is equal to 2 because we just added 1. What's the odometer reading? I'm going to enter garbage. Okay, F8. The valid you entered is not a valid number. Please re-enter. Okay. Now, is attempts greater than 3? No, attempts is equal to 2. So we're going to try again. What's the odometer reading? Minus 200, 2000. Still invalid data. Okay. Please enter another number. Attempts is equal to 3, not greater than, so we're going to give the user one more chance. F8, F8, F8. What's the odometer reading? Invalid data. F8. Okay, the data that you entered is not a valid number. And now, what's the value of attempts? Attempts is 4. 4 is greater than 3. At this point, we say, you've had enough attempts. I'm not going to let you keep running. So what we're going to do is we're going to prematurely exit this method by throwing an exception. I'm going to choose F8 and watch where we're going to go. We're going to jump out of this method and we're going to jump all the way up and terminate the program. So watch what happens when I choose F8. Okay, we jumped all the way to the catch block in the main method where we very first started this program. And then we just simply post a message. Program terminated because exception thrown. The user has exceeded the maximum number of attempts. And then we terminate the program normally, and there we go. So again, exceptions can be used to validate data, to handle things that can go wrong when a program is running, and to gracefully exit a program if we need to. We can simply rethrow an exception until a point that we can gracefully shut down the program. And you see that we posted a message and then we shut down. We didn't just mysteriously crash. If we don't do proper exception handling, it's very possible that we could just mysteriously crash. Okay, so I realize this lecture went a little bit long. Let me review a couple things that you might want to think about for exam question suggestions. This material likely will end up on the exam. Okay, first of all, what are some examples of checked exceptions? In other words, exceptions that you have to handle. File not found, class not found, instantiation exception. These are all things that are checked exceptions. What are unchecked exceptions that you should handle proactively? Array index out of bounds. Remember we did that if test in annuity where we said we're not even going to try to do these array accesses unless we know that we have an array of that size. So array index out of bounds. Also, number format exception. Remember, we're smartly going to capture that to validate that the user has entered valid data. We don't have to do it, but if we do catch it, then we're being more proactive. So those are unchecked exceptions. What are some no-nos? Never have an empty catch block. Never return null from a catch block. If you do that, you're taking very valuable information and throwing it away. What will a finally do? A finally will always execute whether an exception was caught or not. It will typically follow a catch block. Okay, finally will always execute. Okay. If we have multiple catch blocks, which we are allowed to have, as we saw in our monthly runner, we will typically put them in an order from the most specific exception type to the most general. Because if an exception is thrown, it will be caught by the first catch block where the parameter type is the same or a superclass of the exception itself. Also remember, if an exception occurs, it will skip all the lines between where that exception occurred and the catch block that applies. So you have to be very careful and think about where you want your catch block to be. In this case, we put lines between these two that are dependent on an exception not being thrown. In other words, it's dependent on a valid object in the variable mi. However, we did put the entire try-catch within the for loop. So if an exception does occur, it will simply, on the next iteration, pick up with the very next file and process that. So we have to be very specific about exceptions and what we do, how we handle them, where we put the catch blocks. That's something that just takes practice, to be honest with you. Remember that exceptions fall under the category of runtime errors. The other kind of errors we can have are syntax errors, which are the squigglies, or logic errors, where a program compiles, a program runs, and it simply doesn't do what we want to do. So all of these would be great quiz question suggestions. If you put them under exam question suggestions, we'll handle them from there and roll them into the exam. That's all I have for this lecture. The next lecture, we're going to take a look at programming assignment number 3, and we're going to start looking at something fun, which is swing programming, and maybe we'll even throw a couple of exception handlers into that. Thank you.